Hello guys, today we are going to solve this Leetcode question which is diameter of a binary tree, and it's a easy question. Let's go through the question right now. So we are given a root of the binary tree and we need to return the length of the diameter of the tree. So what's a diameter means? The diameter of a binary tree is the length of the longest path between any two nodes in a tree. So basically what's a diameter means we can pick any two nodes and the number of edges between these two nodes is the diameter. So we need to find the longest path or longest length, right? So the important point is that this path may or may not pass through the root. So initially when I read this question, I didn't go read this point, and what I thought was, the longest path always goes through the root, right? But it's not true always. Let's see why in the in this example. But let's finish the problem statement. So the length of a path between two nodes is represented by the number of edges between them. So it's so I hope you got what the problem statement is asking us to do. We're basically we basically have this tree, and what we need to do is we need to find the diameter. What is diameter? Diameter means if we take two nodes, suppose if I take these two nodes, the length, the the path between these two nodes, uh, number of edges between these two nodes is the diameter of the tree. Suppose if you took if you take these two nodes, we have one and we have two. So the path is two. But if you take these two nodes, the length is one and two. But if you take this node and this node, the length is one, two, and three, right? And what if you take this node and this node? The path is one, two, and three, right? So after doing this example, I thought the path always goes through the root, right? I thought that the path always goes through the root because we need to find the longest path, right? But that's not true because if you look at this example, what's the longest path means? Suppose if you take this node and this node, what's the length? One and two, right? But if you take this node and this node, the length is one, two, three, four, five. But if you take this node and this node, the length is 1, 2, 3, 4, 5, 6, 7. 7. So the path may or may not always go through the root. Sometimes it may not go through the root as well. So in this example, this is the path. This is the longest diameter that we can form. So how are we going to solve this question means, you observe carefully here. Okay. Okay, again, let's look at this example. If you observe carefully at any point, suppose if I'm at this point, the longest diameter that I can achieve from this node is the height of the left subtree plus the height of the right subtree. So hey, from this point, what's the height of the left subtree? This is the left subtree of 2, and this is the right subtree of 2. So height of left subtree is 1 plus the height of right subtree is 1, right? So from here I can get a diameter of 2. So let's look at another example, like if we take this thing, what is the height of left subtree? It is 2, right? 1 on 2, or we have 1 or 2. Either way, we only have the left subtree height as 2 plus the height of right subtree, which is only 1, 3. So At this point, I have for one, I have the diameter as 3. For 2, I have diameter as 2. For 4, the height of left subtree is 0 and the height of right subtree is 0. So 0 plus 0 is 0. So the diameter from 4 is 0. And the diameter from 5 is also 0 because there is no left or right subtree. And the diameter from 3 is also 0, right? So what's the maximum value? 3. So our answer is 3. So now let's look at this example. For this node, what's the height of left subtree? 1, 2, 3, 4. And for 4 plus on the right we have 1, right? 4 plus 1, which is 5. So if we come to this node, what's the height of left subtree? 1, 2, 3. And the height of right subtree. You know, you can also have something like 1, 2, but you will take the maximum value, which is 1, 2, 3, 4. You can also have this 1, 2, 3, but you have something like 1, 2, 3, 4, right? So 4 plus, oh sorry, 4 is on the right, right? On the left I have 3, on the right I have 4. So this is 7. For this node, the left height is 2, and the right height is 0, right? For this node, the left height is 1 and the right height is 0. For this node, the left height is 0 plus 0. For this node, the left height is 1 plus 1, 2, 3, 3. For this node, the left height is 1 plus 2. For this node, 0 plus 0, 0 plus 0. This is 0 plus 1 and 0 plus 0. This is 0 plus 0. If you look at all the nodes, the maximum value is 3 plus 4, 7. So how are we going to find the height of the subtree, right? So that's the most important thing. So I'll take an example and explain how we can do that. Let's look at this example in order to find the height of the subtrees. But before that, let's break down the problem into smaller problems. Suppose we only let's say we have this tree. Let's break down this into a smaller problem. Let's say we have only this thing. We have only one and only one node. So what's the height of this subtree? 1, right? When we only have one node, the height of the tree is 1. So let's say if we have something like this, what is the height of subtree? What is the height of the entire tree? I'm saying 2, right? Because this is one level and this is another level, which is 2. Suppose we have something like left subtree and the right subtree. What is the height of this tree? Is it 3? It's not 3 because this is one level and these two belong to the same level. So the height is still 2. Suppose if we have something like this, what is the height of the entire tree? It is the maximum path from the root to the node, right? So it is 1, 2, and 3. The maximum height is 3. So how are we calculating this value? It is nothing but if I'm at this node, if I'm at a particular node, I'll say I have a height of 3 from the left and I'll say I have a height 1 from the right. So what is the maximum value? Which is 3, right? 3. Let's look at this example so that you can get a clear idea. So how am I going to find out the height means? Suppose when I'm at root, I'll say go and get the height of the left subtree and I'll say go and find the height of the right subtree, right? Then I'll come to here. Then I'll say go and find the height of the left subtree and go and find the height of the right subtree. So and from here I'll say go and find the height of the left subtree and go and find the height of the right subtree, right? So if you see I have no nodes here. So when I have nulls, basically when we say we don't have any nodes, we basically have nulls, right? When there is no node, the height of the tree is 0, right? So this will return 0 and this will return 0, right? So now what I'll do is I'll take the maximum of left and right. What's the maximum of left and right? 0, right? 0 plus this node. This node is 1. This node contributes to 1 level, right? So I'll take the maximum of both. What is the maximum of both? 0. I'll add 1 and I'll return 1. So for this node, the left value is returning 1. And on the right, I have no node. So this will return 0. So for this node, from the left I'm getting 1, from the right I'm getting 0. So I'll take the maximum, which is 1, right? 1 plus I'll add this row, right? See, I'm sorry. I will add this level. So this it will become 2. So I'll return 2 to this node. Then I'll come here, right? When I come here, from this node I'll ask go to the left and get the height of the tree. Go to the right and get the height of the tree. From here I will also say the same thing. Go to the left and go to the right. From here I will say same thing. Go to the left and right. This is null and this is null. This will return 0. This will return 0, right? So 0 plus 0, I'm sorry. The maximum of 0 and 0 is 0. I'll add 1 and I'll send it to the upper node. So I will return 1. For this node, I'll get 0 and 0 as well. I'll add 1 and I'll send 1. So the maximum of this one and this one is 1. I will add 1 to that. I'll send it 2. For this node again, I'll send 1. And from here I'm getting 2. And from here I'm getting 1. So I will add 1 to the 2. It will become 3. And from here I'm getting 2. From here I'm getting 3. And I'll return 3 plus 1, which is 4. So the height of the tree is 4, which is 1, 2, I'm sorry, this level is 1, this level is 2, this level is 3, and this level is 4. Or we can also say 1, 2, I'm sorry, 1, 2, 3, 4, right? So this is how we're going to do this. So at every level, what I'm going to do is I'll start from here. So we found out how we can find the height of the height of the subtree. I'm sorry. We find out how we can find the height of the tree, right? So using this idea, we're going to solve the diameter question. Let's see how we can do that. Suppose suppose I'm at this point. Suppose I'm at this point. I'll say go and find the height of the left subtree and go and find the height of the right subtree. And when I get the value from these two values, I will add both. I will add both and I'll return to the top. Suppose I'm doing the same thing on this node. I'll say go and find the height of the left subtree, which is what is the height of the left subtree? 1, 2, and 3, right? 3. What is the height of the right subtree? 1, 2, 3, 4. Wait a minute. Yeah, it's actually we're good. We're good. We're good to go. Like the from this node we'll ask this entire subtree. This entire subtree to give the height of it. So it will give us 3, right? And from here we'll ask this subtree to give the height of it. What is the height, maximum height of this? 1, 2, 3, 4, right? So this will return 4. So we'll just add these two. 3 plus 4, which is 7, right? This will return 7. And this node will say give the height of the left subtree. This has given 7. And what is the height of the right subtree? Which is only 1, right? So just a second. Oh, this will not return 7. Instead, at this point, what I'm going to do is I'll just find the height of the left subtree, which is 1, 2, 3, 4, 5. This will return 5, and the height of the right subtree, which is 1, right? So this will return 1. So the height for this node is 6, but the height for this node is 7, right? So we'll store this 7 as our answer. That's it. Now let's see how are we going to use this approach to solve the question. So let's solve the question right now. We're basically given this. We're basically given the root of the binary tree, and we need to return find. I'm just creating a function called find diameter. So this will return the height of the diameter. Find diameter of tree node of root. So what I said, when my when my root is equals to null, my answer is always zero, right? When there is when there is no node, when we don't even have this root node, the diameter is always zero, right? So that's the base case. And what I said, we need to get the left height. Left height equals to get the height from the left subtree and get the right height of the right subtree. And what will just return left plus oh left height plus right height. So this is for this only works for only one node. So this is the diameter of current node equals to. So we also need to get the diameter of the left subtree. I'll explain you why am I doing this right now. Now what I'll do is I'll just return the mat.max of the diameter of current node, comma mat.max of diameter of left tree, comma diameter of right tree. So basically what I'm doing is I'll explain with an example. Suppose if I'm at this point, what I'm saying is find the diameter of this node. What's diameter of this node? The height of the left subtree, which is 2 plus the height of the right subtree, which is 2. So the height of the right subtree is 2. So the diameter is 4, right? What I'm doing is, I'm taking this diameter and this diameter and this diameter, and I'm finding the maximum of these three and I'm returning them. For this node, I'm finding the diameter of this node, and this node. I'm returning the maximum of these three. And for this node, I'm finding the diameter of this node, and this node, and I'm returning the answer. So that's what I'm doing right here. So we need to implement this function, right? In order to find the height of tree node of root. When I'm finding height, when root is equals to null, I'll just return 0, right? So for this root, I need to find the height of left subtree. The left equals to height of root dot left, right equals to height of root dot right. And what I'll do is I'll take the maximum of both left comma right, and I'll return by adding 1, as I have already said. I don't know if this works or not. Let's try. No, it's not working. Cannot find symbol. Find diameter. Oh, Spelling is wrong. Let's try once again. Uh, Each and every spelling is wrong, but that's fine. Not going to change. Let's submit it. Yeah, it's running fine, but this is not the most optimal solution because at every point, what I'm doing is I'm finding the height of left subtree and I'm finding the height of right subtree, right? So you look at the code, you look at the code, the height of left subtree will take order of n, and the height of right subtree will take order of n, and this will take order of n, right? So for every node, what I'm doing is for every node, I'm going to the left and finding the height of the entire tree, and going to the right and finding the height of entire tree. So it's basically order of n square, right? It's basically order of n square. Uh, we can optimize this solution by using a trick. I'll explain you that right now. Before looking at the efficient solution, let's try to understand the time complexity and space complexity of the above approach. So basically what we are doing is, suppose if we have this tree, let's say we have this tree like this. Suppose if I'm at this point, what I'm doing is I'm finding the height of left subtree, which is order of n, plus I'm finding the height of right subtree, which is order of, at worst case it can be order of n, right? So, and I'm again going to this node and I'm finding the height of left subtree and the height of right subtree. So for every node, I'm doing the same thing. So it is basically order of 2n for every node. So there are n nodes, and for every node, I'm doing 2 into n operations. So it is order of 2n square, which is equals to order of n square, right? When it comes to space complexity, suppose if I'm here, when I'm going to this node, I'll store this in my stack. I'll store this root node in my stack. Then I'm here, right? From here, I'm going to here. So, and I'm again going to store this thing in my stack in order to get back to that again. If I'm at this node, I'm going to here and I'll store this node in my stack. So at most the stack can store order of the maximum height of the binary tree at most. So the time complexity is order of n square. The space complexity is order of h in the worst case, right? So now let's look at the efficient solution. So basically, if you observe carefully, for every node, you're basically finding the same height again and again. For this node, I'm finding this height and again this height, right? And again for this node, I'm finding this height and this height and this height and this height. You know, it, it's uh, it's basically nothing but redundancy, right? There's no need when we calculate the height once, there is no need to calculate the height again and again, right? So using this approach, we're going to optimize the above solution. So let's try to understand how we are going to do that. Suppose we have this tree. Suppose we have a tree like this. So what I'm going to do is, suppose if I'm here, what I'll do is go and find the height of the left sub, go and find the, yeah, height of the left subtree and go and find the height of the right subtree. And for this node as well, I'll say go and find the height of the left subtree, go and find the height of the right subtree. For this node, I'll say the same height, height. This will return 0 and this will return 0, which will be 0 plus 0, which will be 0, right? So So right now what I'm going to do is, I'll at the same time I'll find the diameter of this node. What's the maximum diameter that this node can be generating, which is 0, right? The diameter is nothing but left height plus right height is the diameter. So this node is generating the diameter as 0. So I'll keep a normal variable as dia as 0, as 0. So what I'm going to do now is, initially the diameter is 0, right? So I'll come here and I see that the left height is 0 and the right height is also 0. So the diameter formula is the left plus right? So it is still 0. But now when I'm returning, I'll return the maximum height. What's the maximum height is? Left height is also 0, right height is also 0. But I'll add 1, right? 1 plus 0, which is 1. I will return 1. So the right height is again, this will return 0, this will return 0, and the diameter formula is still the same, 0 plus 0, which is 0. This will remain 0. So, but I will return height, which is maximum of these two, which is 0 again, and I'll add 1 to that. So this node is receiving 1 from this node. This node is receiving 1 from this node. So that what's the diameter? What's the diameter for this node? 1 plus 1, which is 1 plus 1, which is 2, right? So which is greater than the diameter. So this will become 2, and now I'll return the maximum height. So what's the maximum height? 1 comma 1. I'll return the maximum of those, which is 1, right? So I'll add 1 to that and I'll return 2. Then I'll come here, I'll ask this node to find the height, and I will ask this node to find the height. This will return 0, this will return 0. So this will return 0 plus 0 plus 1. What's the diameter at this point? 0 plus 0, again 0. But 2 is greater than 0, right? So there's no point in updating this. And this node from the left returns 1, and this node from the right gets 0. 1 plus 0 is 1. 1 plus 0 is 1. So the diameter is 1, but our diameter is already 2. So there's no point in updating that. So I'll return the maximum of these two, which is 1, 1 plus 1, which is 2. So I'll again find the diameter at this point. I got the answer from from left, I'll get 0, right? So the diameter is 0 plus 2, which is already 2. So there is no point in updating that. So for the height, what I'll do is 0 comma 2, which is great, 2, right? So I will add 1 to that and I will return 3. So at this point, the diameter is 2 plus 3, which is 5, right? Which is greater than diameter. So I will update this. And for the height, I will return the maximum of these two, which is 3 plus 1, which is 4. So at the end, I'll have the highest diameter. So if you observe carefully, in order of n time, I'm just traversing the whole tree only once. By traversing only once, I found the diameter. So this is the updated. No, this is the what they call. This is the optimized solution. So let's tweak this code in order to make it more efficient. So what I'm doing is, from left I'm getting the height of the tree. From right, I'm getting the right height of the tree. Diameter of dot right? Now what I'm going to do is, so I'll keep a static variable, static int dia equals 0. So at this point, my diameter will be mat.max of dia comma left plus right. Right now, when I'm returning, I'm going to return the maximum height, right? Mat dot max of left comma right. For this height, I'm going to add one, right? So this gonna I guess this should work, but I'm not sure. Oh, again, spelling is wrong. Oh, at the end, I need to return the diameter, right? So this is not the answer. Then this will also not work. We need to initialize dia as 0 for every method call, because the static keyword because of the static keyword. This will stay the same for any number of objects that we create, right? So that's the reason. If you look at this, it's getting accepted, and that's it, guys, for the video. If you find the video helpful, you know what to do. Like like the video. That's it. Thank you.